Where did Phobos and Deimos come from? Can we send a mission into a gas giant? How many exoplanets did Gaia detect? What is Canada's involvement in space exploration? Answering all these questions and more in this Q&A show. It's time for the question show. Your questions, my answers. As always, wherever you are, across my channel, if a question pops in your brain, just write it down. I will gather them up and I will answer them here. All right, let's get into the questions. Colin P2238. Is Canada involved in any missions? If so, how much? Canada is definitely involved in space exploration. We have an agency, the Canadian Space Agency. And although it's not anywhere near as well funded as the NASA or the European Space Agency, it does get involved in a lot of projects. So just to give you a few examples, I mean, Canada has built about a dozen satellites, and a couple of the most famous ones are the radar sats. And so these are Earth observing satellites that do radar altimetry, where they scan the surface of the planet, sort of measuring heights, and they're also able to measure, different, forest cover, things like that. And this is sort of very good for Canada. We have a lot of natural resources and we want to try and map them out. So these are some of the satellites that have been built and designed in Canada and launched. Of course, we have contributed to the space shuttle with the Canadarm, to the International Space Station with the Canadarm2, and plans are now being worked on to contribute to the Lunar Gateway with the Canadarm3. And the Canadian budget is we contributed about $1.4 billion to the International Space Station. We've had 17 astronauts fly in space, and one of the most exciting ones is that we're going to have a Canadian astronaut on the upcoming Artemis 2 mission who's going to be flying around the moon. You might be surprised to hear that Canada is building a launch complex. So they're actually under construction right now in Nova Scotia, and it's going to be launching Ukrainian rockets on polar orbits. So it's going to be able to launch into polar orbits to be able to image the entire planet Earth as it orbits down below it. So yeah, Canada is extremely involved in space exploration. The other thing that's pretty interesting is that we have a new lunar rover that is going to the moon as part of the Artemis missions, and is going to be helping to explore the South Pole region around the pole. And in fact, right now, Canadians can help vote on what they think is the best name for the rover. So if you do a search for Canadian rover name, then you can go and actually vote for what you think is a good name for the rover. So yeah, Canada is very involved in space exploration. I think one of the most exciting things, sorry, I almost forgot, is that Canada contributed one of the instruments on James Webb Space Telescope. And that is the Fine Guidance Sensor, the Near Infrared Imager, and Slitless Spectrograph for JWST. And this is sort of one of the 4 major instruments on James Webb, and it was provided by Canada. So Canada has been very involved in space exploration for decades, and I'm sure will continue to be into the future. Sandheaver 44. When Gaia first launched, they said it would detect thousands of exoplanets. How many exoplanets has Gaia actually detected? Gaia's main job is to measure the positions, the composition, the movement of stars in the Milky Way. And it's done an amazing job of that. I mean, I think it's cataloged over 1 billion stars so far. But one of the other sort of side benefits for Gaia was that it would be able to help find exoplanets. Now, it's got 3 ways that it can find exoplanets. The main way is with astrometry. And of course, this is how Gaia is measuring the movements of all of the stars that it sees. It uses the parallax method. Sort of at one point in its orbit, it's on one side of the sun, and then half a year later, it's on the other side of the sun, and then it makes this big triangle where it then measures and watches the movement of stars as they move back and forth in their field of view. But in addition, it can actually measure and see how a planet is wobbling a star with its gravity. The second way is it can use the transit method. So it can actually measure the brightness of various stars in its field of view and watch as planets are passing in front and detect them. And then the third thing is with the radial velocity method. So it can actually measure the velocity of the stars moving back and forth in its field of view. Now, it's not great at both the transit method and the radial velocity method. It's the astrometry method, which is the one that's going going to deliver most of the planet so far. And I did a quick check before this episode, and so far, Gaia has officially found 300 exoplanets, which is pretty amazing. Most of those were detected with astrometry, a few with the transit method, a few with the radial velocity method. But we are only at data release 3, and this is sort of the in-between phase. It's only accumulated a small amount of data, hasn't gotten all of the data that it's going to be accumulating. The mission ends in early 2025. And when that happens, they're going to download all the data. They're going to crunch it all down. And then they're going to release data release 4 sometime in 2026. And it's estimated that Gaia will find about 21,000 exoplanets. Sort of now, not necessarily in data release 4. Maybe it'll come in data release 5, which is probably going to be around 2030. It's going to take that long to process all of the data from Gaia. And yeah, plus or minus 6,000 exoplanets. So it should find 15,000 to 26,000, 27,000 exoplanets, which is pretty amazing. So they've only just found a few so far. That hasn't really been their big focus, but in that data release 4, we should see a huge new list of exoplanets. So wait for that in 2026. Katie 683. The existential question that needs to be answered for my life to be back on track. How did Mars get its moons? That's the existential crisis that you need to get your life back on track. Well, I hope that actually, you know what? By the time I answer this question, you will not have a really satisfying answer. And so I hope you can find some other ways to get your life back on track. But yeah, so Mars has 2 moons, Phobos and Deimos, and astronomers have wondered how it got these 2 moons. And if you just look at them visually, they look like asteroids. And in fact, if you measure the chemicals on the surface of the moons, they are very similar to what are called C-type asteroids. And these are very common in the asteroid belt. And so one of the theories is that Mars got its moons by capturing 2 asteroids. But the problem is that the orbits of the moons and their orbital plane is sort of very hard to replicate with an asteroid capture. They are perfectly in the orbital plane of the rotation of Mars, and they are almost perfectly circular. And if you had captured asteroids, you would expect that they were on very elliptical orbits, sort of off kilter from the orbit, the axial tilt of the planet. So the other possibility was that something really large smashed into Mars a long time ago, similar to what happened with the Earth and the Moon. And that kicked up a big cloud of debris. The debris came together and it formed the 2 moons. And that definitely has a lot of evidence behind it. The most recently, like earlier this year, astronomers proposed a different way, which was that maybe an asteroid came incredibly close to Mars and got so close that it fell within the Roche limit of Mars. Mars, with its tidal forces, tore apart this asteroid. It then it lost some of its orbital momentum. And so some of the parts of it were able to go into orbit around Mars, collect into the moons. And that's how they might have gotten the moons. And so right now, which of those is inconclusive? And there are papers that come out almost every couple of months. It offers different evidence for which of those is the most likely outcome. And the thing that will probably get us our final answer is when the Japanese Space Agency's Martian Moons Exploration mission flies to Phobos. And it's going to be launching in a couple of years. And it's even going to be bringing home a sample. And once scientists on Earth get their hands on that sample, they will be able to compare that to the kinds of rocks that we see on Mars, and we'll get a really definitive answer for where it came from. So you're going to have to wait to get this existential question resolved. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Sean Grossman, Smash Boo, Vince Godby, Alexander Gross, Scott Henry, and Brian Oddens. Join the club at patreon.com/universetoday. No thanks will we ever be able to send a mission into gas giants or ice giants? We have already sent missions into both Jupiter and Saturn. Now, with Jupiter, that came with the Galileo mission. When NASA's Galileo mission got to Jupiter, it released a penetrator probe that was designed to go into the cloud tops of Jupiter and then sort of make its way down and collect as much data as it could before it was destroyed. And it didn't take long. I mean, it only got a few 100 kilometers down through the cloud tops before the increasing pressure and temperature tore it apart. And then when Galileo ended its mission, to prevent the chances of Galileo actually crashing onto one of the icy moons around Jupiter, NASA decided to have it plummet into the atmosphere of Jupiter itself. And same thing, it entered the atmosphere, hit the cloud tops, started to hit higher and higher atmospheric density, and was torn up. And then pieces of metal would slowly make their way down into Jupiter. And then we had a similar thing happen over at Saturn. When the Cassini mission got to the end of life, scientists decided that instead of, having the chance of it crash into one of Saturn's icy moons, can you imagine if it contaminated Enceladus with whatever bacteria was on its surface? Instead, they decided to dispose of it by crashing it into Saturn. And same thing, it, entered the atmosphere, got a few kilometers below the cloud tops, and was torn up by the increasing pressure and winds and all that. So, I think the question that you were hoping that I would answer would be like, could we send a spacecraft down into Jupiter and Saturn and fly through the gas and maybe make her way down to the solid core if it's down there somewhere? And the problem is that, it's not like it's a fluffy cloud of gas. It is an enormous amount of hydrogen, helium, and then other heavier elements that is pulled into a sphere with hydrostatic equilibrium by the enormous gravity that is coming from all of the mass of this planet. At the very core of Jupiter, it is tens of thousands of Kelvin that you have pressures that are so strong that it turns hydrogen, which is a gas, floats around here in our atmosphere, it turns it into a metal. It sort of compresses it down to the point that it behaves like metal. And that's at the very core. But you've also got all these other heavier elements that are mixed in. But really, once you're just a couple of 100 kilometers down into the atmosphere of the gas giants, the pressure and the temperature ramps up. And so it would be a lot more like you hitting water and eventually you hitting a brick wall if you tried to descend further and further into these planets. And so we will never be able to do anything beyond floating through the cloud tops of these planets, which would be super worth doing. It would be amazing to have some kind of balloon mission or something that could hover around high up in the clouds, an airplane that could fly for a while, or a helicopter or a blimp or something like that. Of course, flying a balloon at Jupiter is really tricky because hydrogen is the lightest gas. And so what can you fly that is lighter than hydrogen? The only thing you could do is have heated hydrogen. So if you had like a blimp made of hydrogen that you then heated up with some kind of, you lit hydrogen on fire to heat up more hydrogen, then that would allow you to float above the hydrogen of Jupiter's atmosphere. So it would be really tricky, and we really couldn't go beyond a little bit below the cloud tops, and then the pressure and the temperature would just increase and destroy anything that we tried to send there. Matt Barite, why do people keep mistaking drones, stars, and planes for aliens? This is really interesting. I've been watching this sort of unfolding meme. I don't know what you call this, where people are now sharing pictures of things they're seeing from airplanes or from the ground, which are clearly airplanes. I mean, they've got like a red and green blinking lights. You can see the tail. You can see a headlight in front of this thing. It's an airplane. Now, in some cases, it's a small commercial airplane. Sometimes it's a private, like a Cessna, but they're airplanes. And so people are now like thinking that airplanes are drones. Why would people put put proper FAA guideline, red and green blinking lights on the correct sides if they were trying to be covert. So it's really interesting to sort of see this. And because meme is the word that I would use, but I've been like watching the news and seeing how people are like, maybe trolls are sort of whipping up people to sort of question everything. But the kinds of things that people are say that they're seeing are the kinds of things that we see all the time in the sky. Airplanes, home, stars, as you say. It's really interesting. And sort of when you think about times when you've had this kind of mass belief in the past, but before the internet. And sort of now we see it today. We can see people communicating immediately. They're sharing their pictures. They're sort of jumping on and analyzing the pictures. And often, inevitably, you have someone that's like, I'm a pilot. I know exactly what that is. And then, of course, you've got all these satellites that are being seen as well. So it's really interesting to sort of watch this go on. And it'll go away. Like after, I'm sure, a couple of months from now, it'll all be forgotten. The great drone invasion of 2024. Jared Klatt, how much of a planet's gravity is based on the size of the planet versus the material density of the planet? That's a great question, because I think a lot of people believe when you hear about these super Earth planets that have, say, twice the mass of the Earth or 5 times the mass of the Earth, they're then imagining that this planet's going to have twice the gravity of Earth or 5 times the gravity of Earth. But it really depends on both the mass of the planet and the size of the planet. And that gets you the density of the planet. Is the density that really tells you how much surface gravity you're going to be experiencing on that planet. And like, I don't have all of the numbers in front of me right now, but essentially, if you have like a planet that has, say, twice the mass of the Earth, but but is maybe 1.4 times the size of the Earth, it may only have 1.1 times the gravity of the Earth. And those aren't accurate numbers. But the point being that even if you found a super Earth and it was much larger than the Earth, had more mass than the Earth, it might still be a place that humans could actually walk around on, that you could fly rockets from, that there could be a civilization living on one of those places. So Earth is the densest planet in the solar system, which is kind of surprising because it has less of a metallic content than Mercury does. But Earth is a bigger planet and has more mass, and that mass crunches down the metals at the center of Earth so that it actually has a higher density than Mercury does. I hope you enjoyed the question show. Now, I'm going to give you a recommendation for what I think is one of the coolest science-focused anime that I have ever seen. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Adam Schaefer, Andrew M. Gross, Bear Lake Roofing, David Giltonen, David Matz, Dennis Alberti, Dustin Cable, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Paul Rohrbach, Sean Sargent, Spiderswap.io, Stephen Fowler Munley, and Vlad Shiplin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So my son recommended an anime a couple of months ago, and I hadn't watched it. I finally got around to it. It's called Dr. Stone, and it is incredible. It is one of the most science, is like a love letter to science. And the gist of the story is that some weird, mysterious thing happens and everybody on Earth is turned to stone. And one of the first people to get unturned to stone, unpetrified, is this character who was originally like an absolute science whiz back in high school, and he figures out how to unpetrify people, and then goes about unpetrifying a couple of people. And it is thousands of years after this event happened and everything has sort of gone back to nature, and he wants to try and rebuild civilization and runs into all kinds of issues, but uses science to overcome the problems, recreating antibiotics and giving you like the details of the kinds of technology that are required, rebuilding electronics and other stuff like that. And it is like, if you ever feel like, oh, people always have such a problem with science now, people don't trust experts, people don't have any respect for the scientific method, watch this anime and watch this with your kids. Like, there are some more graphic scenes, and so, you know, your young I wouldn't recommend it for young children, but I would recommend it for people who are, 10, 11, 12 and above. And it is wonderful, and it is like scientifically accurate, and it really explains things, and it really presents the scientific method, and yet also tells an interesting story and narrative. And there's 2 seasons already on Netflix, and I think the 3rd season is about to drop in just a couple of weeks. So now's a really good time to get into Dr. Stone on Netflix. All right, we'll see you next time.